想起模糊的小时候，云朵漂浮在蓝蓝的天空。那时的你说要和我手牵手，一起走到世界的尽头。从此以后我都不敢抬头看，仿佛我的天空失去了颜色。从那一天起，我忘记了呼吸，眼泪啊，永远不再哭泣。我们的爱过了就不再回来，直到现在我还默默地等待。我们的爱，我明白，已变成你的负担，只是永远我都放不开最后的温暖。你给的温暖。姚晨 Let's go。 我对你这么好，你却丢下我想跑。下雨天的时候，只想让你往我怀里靠。雨滴滴落在车窗，车窗被割伤。那瓶带有回忆的伏特加全被我喝光。我独自散步在树叶掉落的街道，耳机循环播放的那首歌曲像是解药。没有你的世界变得四季不再喧嚣。如果可以对你说最后一次 I love you， 从此以后我都不敢抬头看，仿佛我的天空失去了颜色。从那一天起，我忘记了呼吸，眼泪啊，永远不再哭泣。我们的爱过了就不再回来，直到现在我还默默地等待。我们的爱，我明白，已变成你的负担，只是永远我都放不开最后的温暖。最后的温暖是你给的温暖，我们的爱，最后的温暖。我们的爱过了就不再回来，直到现在我还默默地等待。我们的爱，我明白，已变成你的负担，只是永远我都放不开最后的温暖。你给的温暖。
morning, everyone. Can everyone hear me? Can everyone hear me?
Yes, miss.
Yeah, my internet is a bit not okay today. It was kicking me out and not allowing me to join. Okay, so let me share the screen. Okay, so as what we were discussing yesterday, okay, so we are not going to be stressing ourselves with too much of theory information. So I plan to directly use the tutorial questions. Okay, we will discuss the tutorial question, and at the same time, we will refer back to the slide, and we will be uh, covering the lecture also. I think that will be much more better. At least you can see what are the questions, how it is look like, and what you need to cover. Okay, let me share my screen. Okay, can see my screen. Chengji can. Okay, so yesterday I have actually talked about the software quality control, software quality assurance, and how they are actually different. And then I also have started to discuss about the macro classic factor model. Okay, and we have go through the three different categories of factors, and then the 11 type of factors given. Okay, so as what I have mentioned, this part is important. Okay, the difference between software quality control and software quality assurance. Okay, so as what I always mention to you guys, when the question asks you for difference, for comparison, please put in a table format. And when you are comparing, you need to compare based on the same aspect, how they are actually different. Because actually, when I'm marking the midterm test, the first question is about the difference between testing and debugging, right? So when you guys comparing, you actually did not compare from one particular area how you want to show the difference. For example, what is the aim of testing? What is the aim of debugging? So it means I cover the aim area and I compare them. And if I said who is doing the testing, who is doing the debugging, so it means I'm covering at the involved role, and then I'm comparing them. But here some of you, I did not refer to everyone, some of you, you did not even compare. You are just simply saying this one and then this one. So the marks which is given, actually it's a bit difficult, because the comparison of the both side will be carried 2 marks, for example. But now, because you did not compare them accordingly, it's a bit difficult to give marks. So please pay attention when you are comparing or when you are doing the differentiating part. This type of question is something you need to compare them from the same perspective. So, for example, if we want to compare software quality control, software quality assurance, so it means we maybe we can compare them. What is the aim of software quality control? What is the aim of software quality assurance? When we do software quality control, when we do software quality assurance, so your comparison must be in the same perspective, and then how they are actually different. So that is how we need to answer comparison or difference question, so please do take note on that. Okay, don't simply answer thing. Okay, so from what we have discussed yesterday, how we can differentiate software quality control and software quality assurance. In case in the question paper, you see SQC, SQA, it's referring to this, these two terms. So, how we can differentiate them? What is the aim of software quality assurance? The aim of software quality control. Actually, it same like how we say for the non software product, like manufacturing product, they also have a similar aim, but the only difference is the manufactured product we can simply reject it, but when we said a developed software, we try not to reject it because we cannot simply reject it and put a chip sale outside there. So that is the only difference, but other than that, it's still applying the same thing. So what is the aim of software quality assurance, software quality control? So maybe you can differentiate them from the aim, and then you can differentiate them when we do each of these. Then you can differentiate what else we can differentiate. Maybe the example of software quality assurance, software quality control. Okay, so how we can differentiate them? Software quality assurance, what is the aim? Quality control is a part of quality assurance. No, no, this is actually not comparing. If you want to mention why it is a part of quality assurance, please explain. This is also apply for the midterm question because I said, yes, I saw many of you put debugging is not testing. Testing is not debugging. Of course, I know that. That's why I asked you to compare. And another one more thing, what I saw is debugging support testing. How? That is not comparison. Because you want to say that, oh, testing is not supporting debugging. Debugging is supporting testing. How? If you want to say something, you need to make sure that it is explaining how the comparison happened. So, if you want to mention that QC is part of QA, that statement is correct, but you need to explain how it is actually a part of it and why the QA is not part of QC. Do you get? So you still need to mention the comparison part there. So why QC is part of QA? How you can explain that QC is part of QA? What is the aim of QA first? Okay, software quality control, we want to evaluate the quality of the product. Okay, so if you see, that is one important point there. Software quality control, software quality assurance, both of them give importance to the quality, okay, and they do evaluation. But software quality control, they do the evaluation on the product. It means on the developed product, or you can say developed software. But when we said software quality assurance, it will evaluate the process, how we do. Okay, so that is one. This is one comparison where the evaluation happen. So maybe you can also put that, okay, where the evaluation will happen. Okay, then, so our aim here, let's start with the aim. Okay, our aim here, software quality assurance, the aim is we want to reduce the failure rate, we want to reduce the defect rate, and also the rejection of the product. Okay, The aim of software quality assurance, we want to reduce the failure rate, we want to reduce the defect rate so that the client will not reject the end product later. Okay, but the aim of quality control, software quality control, is actually we want to because when it comes to manufacturing side, the aim is we want to evaluate the product. If the product fulfill the quality requirement, it will proceed for shipment. And if it's not fulfilling the requirement, it will be rejected. This is manufacturing side, not software quality control. This is quality control. But when we set software quality control, we cannot apply in the same way. But what we do is we will test the product or we will test the software to ensure that we have successfully reduced the failure rate. We have successfully reduced the defect rate, and we have fulfilled the quality requirement for the client to accept the software. So in case when we do the testing and the software has the defect, still has the defect, it means we need to do the fixing. Because software, we cannot simply reject it. Okay, got it? That is the aim. Okay, so where just now what like what Shenji said, so we are doing the evaluation of the quality of the process for the quality assurance, and for the software quality control we do the evaluation on the quality of the process. Okay, one is product, one is process. Okay, so when we do when we do this software quality assurance, when we do software quality control, is it one time things? Which one is one time things? Which one is like throughout? When we said evaluate the development process, so when we do software quality assurance, when we do software quality assurance, so when we said yes, when we said process, it means throughout the software development life cycle, we have different process to do. So when we said software quality assurance, it means we need to apply the software quality assurance throughout the software development life cycle. So it means every process, every stages when we do a process, it means we need to ensure we have applied the software quality assurance. So it will be throughout the software development process. But when we set software quality control, which is evaluating the product, it means we need to have the final product. So let's assume according to the methodology, whatever we are developing and we have completed. So that is what we call as a product. So we will do after the product has been developed, not throughout the process, but after the product has been developed, and we can evaluate the quality on this developed product. Okay, so that will be when to do that. So when we set example, you can give an example of for example like static testing is example of software quality assurance, because our aim is we want to reduce, or we want to prevent defect in the end product later. But when we said example of software quality control, which is dynamic testing, where dynamic testing, we actually want to test and identify if there is still defect or not before we can proceed with the shipment or deliver to the client side. Okay. And another example you can use also, it's not like example, it's just like another terms what we can use for SQA and SQC is the verification and validation. So verification means every process, every stages, okay, we need to do the verification if the process which we are doing is correct or not. And when we said validation, which is more to the software quality control, where we will be validating on the end product later. Okay, if the product which we develop is correct or not. Okay, can understand the difference? So when you are answering, not only for my course, any course, when you are answering to differentiate, to compare, you need to compare them in the same perspective. Then only we will see both of the comparison done. Because if you simply answer, which is like you just put all the whatever points about testing, whatever points about debugging, but you did not compare them, that is actually not how you do the comparison. Okay, so please do take note on this. Okay, can understand the difference between software quality control and software quality assurance? Okay, the next thing is the Mackel classic factor model. So as what we have discussed yesterday, just recalling back. Okay, so this is the one, okay, where the Mackel classic factor model has three different categories of the factors, which is product operation factor. It means the factor which can be affecting the daily operation of the software. And then product revision factor, which can affect the maintenance activity of the software. And then product transition, which can affect the adaptation of the software to work in a new environment or with a new software. Okay, so under the product operation, we have 5 different factors, which is the correctness, reliability, efficiency, integrity, and usability. And then under the revision, we have maintainability, flexibility, and testability. And then under the product transition, we have portability, reusability, and interoperability. Okay, so that is about the Mackel classic factor model. Okay, then the next question is, what are the difference in term of structures between the Mackel classic factor models, Evan and Markiniak factor model, and Deutsch and Willis factor model? So this one is nothing important, but it's just referring to this table. Okay, the last part of here we have this table where the Mackel classic factor model is the first model. So after that they come up with the alternative factor model. So the difference here is the Mackel classic factor model, they have the total of 11 factor model from the three categories of the factor grouping. Okay, then they have come up with additional factors where there is some changes happen. If you see, they have removed the testability. The testability is no more under the product revision factor, and also under the product transition, they have come up with additional two, which is a verifiability and expandability. Okay, then the second alternative factor model, the same thing, they refer to the first alternative factor model, so they don't have the testability, they have the additional verifiability and expandability, and they have introduced another three, which is safety, manageability, and survivability. Okay, so what we use for this syllabus is the first one, which is the Mackel classic factor model, the total of 11 under the three category of grouping. That's it. Okay. Okay. So this is a very simple question, okay, where in the following table you will find section taken from the requirements document. So there is actually a requirement document for the tender for development of superlab, a software system for managing a hospital laboratory. Okay, so we want to identify the best fit requirement or a factor, okay, according to the given requirement. So since we are following the Mackel classic factor model, this will be the 11 suitable answer. Okay, so it means we need to know if this requirement is talking about the daily operation of the software, or the maintenance of the software, or the adaptability or transition of the software. Then from there, we want to identify which will be the best factor suit for this given requirement. It's a very simple thing. So let's just go through it. Okay, so the first one, the probability that the superlab software system will be found in a state of failure during peak hours 9 to 4 p.m. is required to be below 0.5%. What it's actually referring to. When we talk about the failure during the peak hours and the percentage given, yes, it is referring to the product operation factor, and it's supposed should be the reliability. Okay. Okay, the second one, the SuperLab software system will enable direct transfer of laboratory result to those files of hospitalized patient managed by the MD file software package. The SuperLab software system will enable direct transfer of laboratory result to those files of hospitalized patient managed by the MD file software package. So this is supposed should be another software outside of the SuperLab software. Yeah, I was thinking of that. Interoperability, sorry, interoperability referring to communicate with another software. Am I right? Interoperability. Yes, correct. Okay. So the second one is interoperability. What happened? Okay. Then the third one, the SuperLab software system will include a module that prepares a detailed report of the patient's laboratory test result during his or her current hospitalization. This report will serve as an appendix to the family physician's file. The time required to obtain this printed report will be less than 60 seconds, and the level of accuracy and completeness will be at least 99%. When we said result, it means we are referring to the output which is produced by the SuperLab software. So when we talk about output, it should be under the product operation. And out of the five, which is suitable to talk about the accuracy, about the completeness, and also the output given time. The first five. Please refer back to the samples of requirement given in the slide. Efficiency, is it only about the time? I think it is more to the resources too, right? For example, like hardware, software, yeah. But here it's actually concerned more about the output of the system. So which one is talking about the output of the system? Under the product operation. This one, the correctness. Okay, if you see the output mission, the accuracy, the completeness, and then the up-to-date availability, and so on. So correctness will be the suitable one talking about producing the output. Okay. Okay. So the third one, correctness is suitable, not efficiency. Okay. The next one, the superlab software to be developed for hospital laboratory use may be adapted later for private laboratory use. So this super lab software will be, this is currently for the hospital lab, so will be adapted for another private laboratory use. So it means we are going to bring out the entire software to be working at another place. So which category? Operation, transition, or revision? When we are moving the entire software to work in another environment, then it suppose should be the third category, which is the transition. Because we are not doing maintenance here. We are actually moving out the entire software to run on a new environment. So when we said to run on new place, new environment, new operating system, new hardware, and so on, what we call that? Is it not portability? Portability. Let's confirm it. We have the portability, right? Uh, this is revision. Okay, transition. This one. Is it not? Or is it just run on another operating system in the same environment? Reusability is like not the entire system, but it will be like module. We reuse the module. Then this is the interoperability. Uh, let's check under the revision, because revision, right, it's more to internal use. We are not bringing out the software to another environment. Maintainability, flexibility. Flexibility is more to adaptive maintenance, perfective maintenance. Um, do we have any example here? Then we have testability is not suitable. So which one is the suitable answer? Portability, flexibility. When we say that we are moving out The super lab software to be which developed for the hospital laboratory use may be adapted later for private laboratory use. I still feel like portability. What do you guys think? I'm not sure. Because it is about the software which we are developing for this environment, I mean this lab in the hospital, we can we might adapt it for the private lab later in the future. Guys, suggestions, which one is suitable? Flexibility. Why? Flexibility. We Flexibility is, yeah, for um because flexibility is suitable for adaptive maintenance, right? So it means we are not doing any changes on the software, but we adapt the the software to be working on a new environment. And when we said portability just now, what was it? So it means we are not adapting it, but it's something like it must be able to work on multiple platform, multiple operating system, right? It means when we develop it, it's already portable enough to work on different environment. Okay, now I got it. Okay. So now for the fourth one, flexibility will be suitable because the software must be flexible enough for it to work on another lab, different lab. So it means they are not going to do it now, but they are going to make it in the future because they said may be adapted. So it must be flexible to do that. But when we said portability, it means we actually develop the system which is portable enough to work on multiple platforms. Okay, okay, let's fix it. Flexibility. Okay, the training of a laboratory technician requiring no more than 3 days will enable the technician to reach level C of SuperLab software usage. This means that he or she will be able to manage receptions of 20 patients per hour. So, what is referring here? It means the technician, the ability of the technician to manage 20 patients per hour. So it should be under the operation factor. So what we are referring here? Which factor we are referring here? When we said how fast they can learn and how fast they can use, we are referring to which factor actually? Under the product operation. Which one? Is it not usability? We have usability, right? When we said how fast they learn, because they able to learn not more than 3 days for reach this level C, and they able to manage this number of patient uh, per hour. Okay, so it should be usability. Okay. The Superlab software system will record a detailed user log. In addition, the system will report attempts by unauthorized persons to obtain medical information from the laboratory test result database. The report will include the following information: network identification of the applying terminal, system code of the employee who requested that information, day and time of attempt, and type of attempt. So here we are referring to the unauthorized person's attempt to obtain medical information from the database. So what we are talking about? What we are talking about? It should be integrity, correct? When we said about the security of the data, let me confirm. Integrity. This one. Mm. Okay. Deal with the software system security, that is authorization and access level. So it means how we are actually trying to get all this record about unauthorized person trying to access to the database. Okay. The next one, the Superlab subsystem that deals with the billing patient for their test may eventually be used as the subsystem in the physiotherapy center software package. The Superlab subsystem that deals with billing patient for their test may eventually be used as a subsystem in the physiotherapy center. Are we using the whole Superlab system here? Are we using the whole Superlab software here? We are only taking a subsystem which is dealing with the billing of the patient. So we want to reuse this subsystem for the billing part into another software package in the physiotherapy center. So it means we want to do the transition, and it will be reusability. It means we able to reuse that particular subsystem into another center. Agree? Because we are not doing anything with the whole Superlab software, only that billing part, which we want to make it as a subsystem in the physiotherapy center software package. Okay, can I? Okay, the next one is the Superlab software system will process all the monthly reports for the hospital department's management, the hospital management, and the hospital controller according to Appendix D of the development contract. What does that mean? This report all must be according to what is mentioned in the appendix D of the development contract. So let's assume the development contract, the appendix D of the contract say that okay, this is how the report suppose should be, the monthly report for the hospital department, for the management and so on. So which factor is referring to this? Are we referring to the correctness also? That the report must be correct based on what is mentioned, because they talk about this. This is output, right? The monthly reports which need to be produced for these respective departments must be follow based on what mentioned in appendix D of the development contract. So can it be correctness? Because it is under the operation, it's not revision or transition. Can it be correctness? What do you guys think? Because when we talk about the reports generated, it's about the output, and it must be accurate based on what is mentioned. It means it's, sorry, not accurate, it must follow the standard whatever mentioned in the appendix D of the development contract. Why testability? We are not doing any testing here. No. Are we tracking back to the requirement? Testability, where is it? Mm. Deal with the testing of an information system and its operation. No, this is actually more to maintenance time, When we do the product revision, right? It means when we do the maintenance, doesn't matter whichever maintenance, adaptive, perfective, or corrective. So we need to test the software back, right? Then the software must be able to be tested after that. So we refer to the testability. So it means this part, by the maintenance team to detect after the maintenance part. But here, this is actually nothing much about testing. This is, we want to confirm that the monthly reports must follow the maybe whatever requirement or whatever standard mentioned in the appendix D for us to produce the report. Because if you remember just now for the correctness, right, we have the last point which was referring to this, where is it? Correctness. This one. The standard. So that's why I was saying, because it is under the operation, it's not under revision. This statement did not referring to the revision side. It is under the operation of the software. So that's why I'm saying correctness. What you guys think? Because it's something like the monthly report is the output, very right. So this output must follow the standard as what mentioned in the appendix D. So that's how I try to understand this requirement. So for now I put correctness first, because I did not see something else. So in case if you have different answer, let me know. Okay. The next one, the software system should be able to serve 12 workstation and 8 automatic testing machines with a single model, AS20 server and a CS25 communication server that will be able to serve 25 communication line. And this hardware system, so we are talking of hardware system here, should conform to all availability requirements as listed in Appendix C. So just now we talk about hardware means referring to, it means the system able to serve with these numbers of hardware. We are referring to, it should be under the product operation factor. And which factor? Brandon, just now, the first one, what you said should be the efficiency. It means the system able to work, able to serve this many of workstation numbers and the testing machines and also the communication server. So when we refer to hardware, how much hardware, how fast or the supporting level, so we are referring to the efficiency. Okay, huh? Can I? Okay, the Superlab software package developed for the Linux operating system should be compatible for application in Windows NT environment. So which one is this? When we said it must be compatible to run on different operating system. Which one was it? Yes, portability. Huh? So I think the flexibility and the portability is clear now. Okay. I sorry, what I did. Okay. So that's just example of the factors and the requirement. So the next question is list and explain the component of the software quality assurance system. Okay, so this is where actually I stopped yesterday. So under software quality assurance system, okay. So this software quality assurance system is referring to a combination of a few components to work together to achieve the software quality. Okay, a combines of software quality assurance component which can work together, okay, to achieve a certain acceptable level of software quality assurance. So we have total of 6 different components, okay. uh, Let me go through briefly one by one. So pre-project component is normally components which we need to take care of before we will start with the project, like the contract, okay, to do review on the contract, to do the early development and the quality plans so that our project can move on without any issue and we can we can achieve the quality. Okay, then the second one is the software project lifecycle component, which is covering the 2 stages, which is the development lifecycle stage and also the operation maintenance stage. Okay, so it means how we can do the detect of the errors and then how we can do the testing, how we can improve the maintenance task. Then the third one is infrastructure components for error prevention and improvement. So this one is how we can, because we cannot totally have zero errors or zero defect, but we always try to prevent the fault or the defect to happen. and also how we can lower or reduce the rate of the defect. Okay, so something like a proper procedures, work instruction, any checklist, any training, documentation, any preventive and the corrective actions. So those kind of things. Then the fourth one is management software quality assurance component, which actually can control the development and the maintenance activity from the management perspective. So where it is covering the cost, the timeline, and then the resources, and then the calculation for the quality by using the metrics and so on. Okay, then the fifth one is the software quality assurance standard system certification and the assessment. So this is more like involvement of the standard organization, for example, like IEEE, ISO, maybe CMM. All this we will discuss in chapter 12 later. So how actually they can provide the standard for us to improve the quality of our process and also our product. Okay, and then the last one is the human component. So the human component will be the people who involved in the software quality assurance areas, the managers, the testing people, any professionals under the software quality assurance. Because without this human component, the balance five component just now is useless, because they are the one going to develop, they are the one going to implement, and they are the one going to improve all this software quality assurance time to time. Okay, so that is the six components. Okay, then the next one, list and explain the software quality assurance activities in software testing. So please do take note on this, where we will have six different activities in software testing. It means software quality assurance activities in software testing. Okay, so there will be total of six different activities. So it means how we can apply these software quality assurance activities in our software testing to make sure that our software testing can move on better, we can achieve the software testing accordingly, and we will have better, I mean, like efficient software testing. Okay, so the first one is plan the testing and the software quality assurance process. So it means every time when we want to do the testing, we need to do the planning accordingly. So we might be having this one first, test plan. So you should know by now what is test plan, test case. So all these need to be produced, need to be planned accordingly. Other than that, quality management plan also might be needed, but since we already include inside the test plan the quality part, the risk part, then sometimes we don't need this. Okay, so this is the first activity. We need to plan the testing and also the software quality assurance process accordingly before we start the testing. Okay, the second activity is implementation of test oriented management. So it means we give importance to the test oriented. So our methodology, which we want to use, must be giving importance to the testing. So one of example of the methodology is actually the extreme programming methodology. I think you have heard that. Okay, so this extreme programming methodology, it's actually giving importance to the quality of the software by providing effective testing. So one of the way is test driven development. So test driven development is where the test case will be written before the implementation of the code. So it means test first approach. Okay, so if you see, this is saying that when we want to have a new function or new feature, okay, before we implement the code, okay, we will be writing the test case, and we will do the automated test case execution before we write the code to fulfill the function. Okay, so let's assume like I want to add a create function. Okay, but before I do the code for that create function, I do the automation test case first. Okay, and when I execute this test case, what will happen? Of course it's going to be initially fail because I don't have code yet. So when I test, it's going to fail. So now our aim to write the code is actually to make sure the test can be passed. So it means when I do the test execution for the second time, it must be passed. So it gives importance that, okay, the test the code which we are developing must be to make sure the test case to be passed. So normally what we do the coding and then we test the code, okay, and then we fill up either it's a pass or fail. So if the code is doing what it's supposed to do, then it's pass. If not, then it's fail. But here, this test-driven development, do the test first with the initial empty test case without completion of the code, and the initial failed test case must be passed after the code has been done. So this methodology believes that this gives importance on the testing. Okay, then the second method is the pair programming. So this extreme programming also introduced the pair programming, where I have discussed this before. Two developers will be sharing the work, and then one person do the code, another person will test the code or review the code, and they will exchange this role. So one is the driver, one is the navigator. So they will be working together. Okay, because when programmers share work in that way, we can easily see the other person's mistakes, errors, and then we can fix it early stage. Okay, so that will be the second software quality assurance activities. So the third one is to ensure suitable work environment for the software quality assurance team. So it means the SQA team, the testing team, okay, need to have a better work environment. So how we can give them a better work environment? We need to make sure that the SQA team, we can also say the testing team, okay, will be involved in the software project from the beginning, so that they can start to do the testing as early as possible. Okay, and then they need to have a good relationship between the testers and also the development team, so that they can respect each other, they can have good communication to avoid any misunderstanding, so that what they are building, it must be able to be tested, so that we can how to say, we can avoid many issue during the testing later if we don't communicate with the development team. Okay, then other than that, we can also provide or try to expand the software quality assurance team knowledge to improve their work. Okay, so this is the third activity. The fourth one is optimize the use of automated tests. Okay, so compare using manual testing all the time, we can improve the quality of the software. It means we can how to say, improve our testing process from manual to automated. Okay, because when we said manual, it is involving with human. Okay, the human resources. So sometimes human resources cannot able to cover the testing. Okay, they can cause any errors due to tiredness and so on, especially when we are moving forward with the new methodologies. So for example, like agile, okay, you guys know that agile, how short will be the timeline, how frequent we need to do the deliver out to the client. So depending on the manual testing might not be efficient enough. So it is very important to increase the test automation. Okay. Then the fifth one is employ code quality measurement. So it means when we do testing, when we want to do testing, we need to make sure that we employ a proper quality measurement where we are not doing any assumption. Because when we said how to say uh, assumption like a qualitative way is you don't have a data, you don't have a fact, you are just assuming, okay, this software is good, okay, this software can perform well, it means just assumption. But when we said we want to employ a code quality measurement, it means we have a proper matrix which we can use for calculation so that each of these quality can be measured, can be documented, can be reviewed, and can be tracked. Okay, so part of it we have the reliability, we have the performance efficiency, security, maintainability. Okay, other than that, rate of delivery and also testability. I will use this table, will be much more easy. Also the usability. Yeah? So if you see how we can measure the software quality, it means when we do the testing without just assuming, okay, we are moving from qualitative way to quantitative way. So it means we have a proper software quality indicators like the one I have listed just now, from the reliability, performance efficiency, security, maintainability, rate of delivery, testability, and usability. Each of these quality indicator need to have its own proper test matrix. So when we set matrix, it means we have data, we have input. Based on this input, we do the measurement, we know the output. From the output, we know if this quality indicators has been achieved or not. So we move from qualitative to a quantitative measurement. So that's what we will be discussing in chapter 11 later. Okay. So for reliability, for example, using number of failures based on our service calendar time, and then performance efficiency by using load testing, stress testing, response testing, we can confirm that. And then security based on how many times there is failures happen, there is number of error messages happen due to any unauthorized access and so on. Maintainability we can do based on the line of code, it means the size of the software. Rate of delivery will be based on number of stories. Stories here normally is used for a certain methodology. They use the word story, and sometimes they use how many deliver out they do. Okay, like how many features, how many functions they will deliver. Okay, and then testability based on how we do the testing, the technology we need for the testing, the tools which we need, the documentation. And then usability is based on the satisfaction level and also the completion rate. So it means how fast the software can be used by the user for them to do the daily operation. So this is also part of the software quality assurance activities in software testing. And then the last one will be report bugs effectively. So in chapter 9, we have discussed about reporting, defect reporting. So it's just same thing, huh? Bugs reporting. Different companies, they use different terms. Okay, it's just the same thing. Defect reporting or bugs reporting, it's referring to the same thing. Okay, so how well we do the defect reporting, the bugs reporting, it is very important because as what we discussed in tutorial 9, this defect reporting become a medium for testers to communicate with the development team after they identify any defect during the testing. So they need to describe the defect in an effective way, okay, so that this defect report can be helpful to make the software testing more efficient, so that the development team can identify what is the problem, where is the problem. Because when we say defect, when we say unexpected behavior, so it means it can be, the report can be helpful for the development team to identify the problem, and also it can be a navigation between the testing team to the development team towards solving the defect, so that the system can be function well and the testing team can continue with the testing. Okay, so this will be the negative impact if the report is not good. Okay, so that will be the 6 activities in software testing. Sorry, I was very happy that my cough didn't come. Okay, got it? The 6 activities. So it's a software quality assurance activities which we can apply in software testing. Okay. Then the next question is discuss the benefit of applying software quality assurance activities, and also discuss the challenges in applying software quality assurance activities. So this is a very general question. Any logic answer should be able to apply. So when we said benefit of applying software quality assurance activities, it means we can ensure that our end product will be with high quality, and we can reduce the failure rate, we can reduce the defect rate. Okay, uh, we can ensure that our what we call that, our software development process will be with high quality. Okay, so we might not have any problem maybe in the area of cost, because if we have any issue to deal after the software developed, then it means we are going to waste a lot of money, we are going to waste a lot of time, and also resources. So if we apply the software quality assurance activities from the beginning, it can give us the benefit to avoid all the major issue later. Okay, so that can be any benefit. Okay, and when we say discuss the challenges in applying software quality assurance activities, then normally what can be the challenges? Maybe the time. Okay, because it will be time consuming, because we are already busy with the project, so now we want to implement something new. So it means we want to implement software quality assurance activities in every process we do. So it means it will be something time consuming. Other than that, when we want to implement something new, of course we need additional resources, we need additional professions who can guide us, and then we might need additional budget. So all this can be part of the challenges when we want to apply. There is no limitation in applying SQA activities. It means there is nothing harm to apply. But for us to start to apply, we might deal with challenges. So please don't get confused between challenges and disadvantage. So when we say challenges, it means the first step when we want to apply the software quality assurance activities, we might face some challenges. So after that, if we able to stable it, then it's only give us the benefit. Okay, so that will be the thing which I want to cover for software quality assurance, which is our chapter 10. Okay, got it? So I done cover chapter 10. Any question before we move to chapter 11? Everyone okay? Can I? So this is more on introducing the software quality assurance and what type of software quality assurance activities we can involve in the software testing. Okay, good. Everyone okay? Before I move to chapter 11. Okay, huh? Okay, I believe yes. So chapter 11, it's the continuation of the software quality assurance, and we are going to discuss more on the software quality metrics. So remember just now, I say that we don't want to use any qualitative way in doing any conclusion. It means we are not going to do any measurement without fact, without data. So uh, give me 1 second. Okay, so we want to ensure that, okay, we use a proper matrix. Okay, when we set matrix, it means we have a standard for measurement. So when we said we want to measure the quality of the process, the quality of the product, so we need to have a quantitative way or quantitative method how we can do the measurement. Okay, so this software quality matrix, it's referring to the measurement of attribute, okay, to ensure the software quality of the process, okay, and also the product. So it means throughout the development, the process, and also the product. Okay, so this is just an example of definition given, a quantitative measure. So this is what I was saying. We are not doing any qualitative way. So when we want to measure any attribute for us to know, okay, what is the code errors, what is the design errors, or maybe how is the productivity of the human resources for this project. So all this we cannot just assume. So we need to have a quantitative measurement to measure the quality attribute. So when we said we have a quantitative measurement, it means we have data. So our data here will be provide, I mean, like we have the input which is coming from the software, from the project. We have the data and we use this for the measurement so that we can get the output. So when we get the calculated output, from there we can know how is the level of the quality, how is how good is the system, how bad is the system. So we can actually get the number from there, and from there we can decide what we are going to do about this issue. So that's why we cannot just deal with a qualitative measurement. We need a quantitative measurement to confirm certain quality attribute. Okay, so let's directly see the question. Okay, so this is tutorial 11. We have two different question of set of question. So one is more to the front part, okay, Then you also have the second part. This is actually from the past year's question on the calculation part. So what we discuss here, that's what you will see. Okay. Okay, so let's see the question one. Explain the difference between process matrix and product matrix. Okay, so when we said we have the software quality matrix, the quality matrix will be process matrix, product matrix, and also we have the project matrix. Okay, so when we say process matrix, this is related to the software development process. It means the development, the coding, the designing, the scheduling of our software development process. So the process matrix here is measuring the quality attribute throughout the software development process. Okay. And when we say product matrix, it means we will do the measurement on the product after the product is being used by the client. It means we have done with the development and the software is already implemented at the client side. Client started to use the product and it is related to the software maintenance of the product. That is what it means by product metrics. And when we say project metrics, this is more like the quality, the timetable, productivity, which can actually part of the process also. Okay. So for this syllabus, we will cover only these two, the process and also the product metrics. Okay. Sorry. Okay. So product metrics, okay, since we said software maintenance, okay, software maintenance means when our client started to use the software, they need this software maintenance, okay, because they will need service on the software being used. Okay, so when we say product metrics, it focus on customer service performance because we need to provide the service to the customer so that the customer can use the product without much issue. Okay, so the question here asks list types of services, explain the difference between the services, give an example of the difference, and what are the major metrics in the product matrix. So I will directly show here. So under the product matrix, this is all process. Okay. Under the product matrix. So this is where we start the product matrix. Okay. We have two types of customer service, which is the help desk service. I think all of you have done that. Help desk service, you call the help desk. And the second one is corrective maintenance service. Okay. Still remember what is corrective maintenance? It means when there is any defects, any fault on the product, so we will do the corrective maintenance. Not perfective, not adaptive, only corrective. So this will be the two types of service under the customer service, help desk service and also the corrective maintenance service. The second question just now, what is the difference between these two services? Help desk service is actually based on the customer call. So it means when the customer use the product, they face any difficulties or they face any issues, maybe they cannot use the application, they cannot use the software, so they will call the help desk. So the help desk team, okay, or the software support team, they will actually try their level best to solve the problem based on the call which they receive. As usual, help desk service. And when we said corrective maintenance service, this will be based on the failure report. there is a failure happen, and then it has been formally reported, and based on that failure report, the corrective maintenance will be done. So it means the maintenance team will do the corrective maintenance based on the failure report. Okay, so this failure report sometimes can be coming from the customer, or sometimes the maintenance team themselves, while they are doing the maintenance, they identify any failure, so they can also be part of the failure report, and they need to do the corrective maintenance service on the product. Okay, so this is the two types, and this is the difference of them. Then the following question just now, what is the example? So example means whenever customer face any issues, for example, for example, um, okay, I like to use TM as a best example, who I always deal with, right? TM. So whenever there is any issues, like just now my internet was down, and I don't know how to fix it. Okay, I don't know what is the problem, why all of a sudden there is red light on the modem, for example. So I call the help desk. So what they will do, they will try to guide me how to fix this issue through the phone call. Okay, through the phone call. So they will say, okay, can you please restart this, can you please try to check this and that. Okay, so this is what the help desk service do. But let's assume I still cannot get the internet connection. So what I will do, I will do the failure report. So I will make it official report that something is wrong. I have done everything what the help desk people say just now, but it still cannot be fixed. So now there is a failure report, and the corrective maintenance need to be done. Okay, so it means the team, the technician side, they will actually do the checking, maybe at their site, or they need to walk in to do the fixing, something like that. Okay, so help desk, they try their level best to solve the issue, and if it's able to solve there, then it will end there. But if it's not, then it will move to the failure report, and the corrective maintenance team need to do the service after that. Okay, so the next question was, what is the major matrix under the product matrix? It will be this four. Okay, we have the help desk quality matrix, help desk productivity and effectiveness matrix, corrective maintenance quality matrix, and corrective maintenance productivity and effectiveness matrix. No worries about the matrix. I will let you know which is the one you need to focus to. Okay. Okay, so done with this question. Okay, help desk service are vital for successful regular use of a software system, because when you face any issues in your software or in your product, okay, the first people you look for is the help desk, because you want to get the feedback, the solution, so that you can continuously to can use the product. So if this help desk service, they are not providing the service accordingly, it means you might stop using the product. Okay, so suggest situation where the help desk service is a failure, and what metrics can be applied for the failure situation in question A. Okay, so normally when we say help desk service is a failure, when we can say that help desk service is a failure, it means like I'm done with this. I really faced this one problem. When was that? Last year. Is it last year? Yeah, it's 1 year. Last year, May, I lost my car. Okay. Um, Honda. I lost. Seriously, I lost it. I just parked, and then because I was tested positive that time, so I did not go to campus. Okay, I was doing online class. Then after that 2 days, then when I came to check, my car is not at the parking lot. Can you imagine that happened? My Honda HRV. Wow. I called Honda. I want to call Honda customer service. Like I was panicked. I don't know what to do because I want to know like if there is any ways they can track the car or something, because I was so confident. I did not fix anything on myself. It means I don't have the tracker by myself because I thought, okay, maybe this HRV they have something, where they can track. So I just, it didn't cross my mind to fix something by myself. So wow, when I called the customer service, they did not pick my call. I have been calling before, because I was waiting for someone to come for us to go to Balai to make a report. So I was calling. Nobody answered. And then I call, someone answer, and then while you are talking, the call end. Then you try again. Then you need to start everything again, while you are in panic, while you are crying like you lost something. And it was really a disaster Friday. I still remember it was Friday. It was a disaster Friday, and I was like, oh, I suddenly thought of, okay, let's call the sales guy, who deal with me to sell the car, right? And he can simply say that, oh, we don't have such a tracking system in the car. Done. Can you imagine how is the service? And can you imagine how should be the service for me to buy the car in the beginning? But when I lost the car, when I tried to communicate with them, this is how they did. So this can happen. Huh? So when we said help desk service is a failure, when we can say that it's a failure, when we can say the help desk service is a failure, in your personal opinion, is it when they don't pick the call? Is it when they don't solve the issue? Which one you will say is a failure? I'm done with this product. Their help desk service, their customer service is so bad. When we can say it is a failure. Actually, when they don't solve our problem, am I right? You are dealing a problem with this product, and you contact them so that they can guide you, they can solve it, so that you can continue to do what you are doing. So when they don't pick your call, it means it is part of 50%, it is a failure. And let's assume they pick the call, and at the same time they don't able to solve the issues what you are dealing. So we can say that help desk service is a failure when the help desk service team did not able to solve the issue. Then we can say help desk service is a failure. Okay, so the next question, what metrics can be applied for the failure situation? So let's refer back. Okay, under the help desk service, we have these two. HD is not for high definition, is help desk. Okay, so if you see under the help desk quality matrix, we have these three different metrics, which is the help desk call density matrix, which is measuring the number of call, severity of help desk call matrix, which is more on the severity of the issue. What are the issue customer always call about? And then the success of the help desk service. So when the level of success in responding the calls and then to complete the issue. So under the help desk, the success just now, okay, this will be, okay, measuring the problem which is raised by the customer can be solved within the given timeline or not. So this will be the answer for this one. What metrics can be applied? So we can say that we can apply the help desk quality matrix, which is measuring the success of the help desk service. Don't worry about the formula, where the help desk service able to solve the problem raised by the customer within the given time or not. So if all the time they don't able to solve the problem, it means it's a failure. So if they able to solve, then it is indicating the success. But if it's not, on the opposite, it will be the failure. Okay. Okay, no worries much. It's just for theory things, for me to answer the tutorial question. Okay, now here we come. It's a calculation. Okay, so this is under, let me show you where you will find this, because for your own reference later. Okay, just now we have said that we cover the process matrix and the product matrix. Okay, process matrix is more to the software development process, while the product matrix will be more onto the product after the client started to use during the maintenance side. Okay, so when we set process matrix, we have these four different grouping of process matrix, which is the software process quality, software process timetable, error removal effectiveness, and error process productivity. So this question which we are going to discuss now, it's a calculation question. This is under the first one, which is the software process quality matrix. Okay, I'm going deeper into that. So under the software process quality matrix, we have two, which is the error density and the error severity. So during the software development process, we deal with errors. So this can be development error, or this can be code error. Okay, so this question is actually referring to the density of the error. So it means we are focusing on the error density matrix. Okay, we have these two, right? Error density, error severity. So we are covering the error density matrix. Okay, so let's directly see the question. A software development department applies two alternative measure, which is NCE and WCE. So this NCE and WCE is actually referring to the number of code errors and also weighted number of code errors. That is the mean of NCE and WCE. So let's see. To the code errors detected in its software development project. Three classes of error severity and their relative weights are also defined. So if you see, the error is actually categorized into different severity classes, where we have the low severity error, we have medium severity error, we have high severity error. So each of these class, they have their own weightage. So low severity have 1 weightage, and then medium is 3 and high is 10. So normally this number can be changed according to the question. Okay, so Now the question asks you to draw the table as discussed in lecture. So the table here referring to this table. Okay, slide 11. This is the table. Okay, if the question asks you to draw the table, you will draw this table. If the question didn't ask you to draw the table but directly do the calculation, it's your option. It is like it's your choice. You want to draw the table to show the calculation, you don't want to draw the table, just directly do the calculation, no problem. But if the question say draw the table, that table must be there. Clear? Please pay attention. Okay, so you need to calculate the NCE, the WCE, the number of code error, weighted number of code error, when there are 59 low severity errors, 20 medium severity errors, and 11 high severity errors. So it means they already give us the number of the error under each of the class. Okay, so let's see how the table look alike. So the error severity here, okay, it means we have the three classes: low severity, medium severity, high severity. This is example. When you draw the table, you need to apply based on that number given on the question. Okay, and each of these severity class, they have their own weightage. Okay, just now in that question the weightage is different. Okay, then they already give us the number of the errors for each of the severity. They already give us, remember, they have the three numbers just now. Okay, so once we have this number, for calculate the weighted errors, it means you need to multiply the NCE, which is the number of code error, with the weightage. Then you will get the WCE, weighted number of code errors. You will get that. Okay, then after that you need to total up the NCE. So it means from top to bottom you total up, and then you will total up the WCE, because you will need this for your next question. Got it? Can understand? uh, this is an image. Let me try to put. Okay, can I know the weightage just now? Low severity, what is the weightage? I'm not going to change the slide. What is the low weightage? Low severity, what is the weightage? On the question, it's given 1. Medium severity, uh, Sanji, what is 2? Okay, 3. High severity, okay. I think high severity is 10. Okay, correct. Okay, can I get the number of the error for each of the classes? Low severity, the number. It's follow low to high, right? 59, 20, 11. Correct? Okay, so calculate each of these. So weighted code errors, 59 times 1, we get 59. 20 times 3, we get 60. 11, 10, we get 110. Correct? Total up this, what we get? Total NCE. This one don't total up. Okay, this one, what is the total of NCE? Total of this, what we get? 90. Total of WCE, 59 plus 60 plus 110, what we get? guys, faster. What we get here? 2 to 9. Okay, huh? I didn't do the calculation. Okay, so that will be the table, okay, where you need to calculate the total of the NCE, right? And then you calculate each of the WCE, and then you total up the WCE. So you get this value 90, and then 59, 60, and 110, and then 2 to 9. Okay, the next thing is if KLOC. So if you see, before we will do any measurement, we need to know what is the size of the software. Sorry. We need to know what is the size of the software. Okay. Okay. So normally we can measure the software size or the system size. Okay. How am I going to go out? Okay. By using KLOC or by using function point. Okay, my question is more to KLOC. I don't use function point, but I will discuss it also. So KLOC, it's referring to thousands of code lines. You always use LOC, line of code. How many lines? That can indicate the size of the software. The more bigger number we are having, it means we have more code and the software is actually like more complex. Okay. Here, the K is actually stand for kilo, which is presenting 1,000, 30. So when the question say if KLOC is 40, it means it's referring to 40,000 line of code. You don't need to add the 30 at the back because it's already presenting the thousands. So just directly use the 40 into your calculation. Okay. The next one is using function point. So function point is normally more on how much resources we need. Okay. For example, to develop this program based on this number of modules, this number of functionality, how many developers we need. So that can also indicate the system size or the software size, but I don't use that. I refer KLOC. Okay, so let's see what the question asks us to do. If KLOC equal to 40, it means 40,000 line of code. We need to calculate CED, okay, and WCED. So let's see what is this, okay. So this CED and WCED. Okay, you can see the meaning here. CED refer to code error density. WCED refer to the weighted code error density. So this will be the two formula you need to use. This one, this one for the code error density. This one is for the weighted code error density. So just now you have calculated the total NCE and also you have calculated the I suppose should be NCE. Is it WCE, which is the weighted NCE. So from there, you will insert into this calculation, divide with the KLOC, and you will get these two answer. Okay, just now, what was it? The NCE is 90, correct? The, the NCE was, okay, the NCE was 90. What is it? Okay, 90. And here was 229. So what is our KLOC? What is the given KLOC just now? 40. Okay. You should get the answer in decimal places. You can use 2 to 3 decimal places. So your CED, what you get? 90 divide 40. What you get? Okay, thank you. Okay, so CED 2.250, WCED 5.725. Okay, uh, it's okay. You don't need to write anything at the back. Just put the number is sufficient enough. No need to mention anything like uh, 2.250 code error per KLOC. You don't need to write all that. Okay, just give me the number is enough. And also you need to show the calculation step by step. I don't want to see only the last answer. So it means you need to memorize this matrix, okay, the formula, and then you need to show how you apply the value and then how you get the final answer. Okay, can understand? So if the question asks you to draw the table, refer back this table just now. Okay, this is the format of the table. If the question just asks you to calculate, don't waste time on drawing the table. Directly do the calculation. Okay, for you to get the total of NCE and then WCE for each of the class and then total WCE. Okay, the question will clearly mention what are the things you need to calculate. The value all is already given here. You just need to apply it into the calculation. Okay, got it? So this is the first calculation matrix which you need to know. It is under the process matrix, under the software process quality matrix, and it is error density matrix. This is the first calculation question. Okay, can? Okay, let's end with these last three questions. Then after that, next week I will continue with the balance calculation question. Okay, so consider the two requirements for the successful software quality matrix.